Hi, today I will introduce you to vector algebra. Vector is an important concept in physics. So there are many quantities such as forces, velocity, are represented as vectors in physics. Let's see an example of vector in one dimension. Let's take displacement along an axis. So we are considering a one-dimensional axis. So this is an x-axis, and here this is a point. Let's call it 0. This is -1, this is 1, and this is 2. This is -2. So let's suppose point P is at -2. This is point P. And point Q is at 1.5. So it is located at 1.5. So let's call it that this is xp and this is xq. Let's call it xp and xq. Now, the point P is located at xp, which is -2. And the point Q is located at xq, and it is at 1.5 units. Okay, let's call it unit. Now, so the distance between P and Q is the point xq minus xp. Okay, therefore we get 1.5 minus -2, which will give you 3.5 units. So this is a distance. Okay, and distance is always positive. Okay, it cannot be negative, because there's a difference between distance, which is a scalar quantity, and displacement, which is a vector. Now, I told you that distance PQ is 3.5 units, which is positive. Okay. Now, let's calculate displacement. So displacement, to calculate displacement, we have to introduce a vector. Okay, so PQ with an arrow to represent a vector quantity. So PQ is a vector from P to Q. So this is PQ. So from P to Q, so this is a vector PQ. And this is a vector QP. From Q to P, this is QP vector. Okay, displacement can be represented as QP or PQ. Okay, remember that they are both different things, and they only differs by their sign. It is either positive or negative. So let's assume we want to calculate PQ. Okay, so it would be the distance at point the xq minus the xp. So xq minus xp, xq is 1.5 minus xp is -2, which give you 3.5, so positive 3.5. So now we are defining the positive direction to be here. So this is a positive direction. The PQ is a positive direction. Okay, we get plus 3.5 units. Now if we calculate QP, okay, which is xp minus xq, xp is -2 minus 1.5 is minus 3.5 units. So it is in the other direction, so it is negative. Okay. So This new quantity now is called displacement because it is represented either by a positive or negative sign, unlike the distance, which is only represented by a positive sign. So we have already calculated the two vectors. Now let's see a small example on vector. So suppose you are at a point, let's call it point B, and you travel along the east direction toward another point. Let's call it C. Okay, and you covered 80 meters. So if we are defining direction, so this is a north, east, west, and south. Now from the point C, you travel at 25 meters towards the west direction, and then you reach point D, and from point D you travel again towards the east at 50 meters, and you arrive at point E, and then from point E you're here, you travel back along the west direction, and then you reach a point over here, so you travel at 100 meters, and then you are only some distances from your starting position. Okay, we don't know what is the distance. So you reach at point F, which is a stopping point. So this one is the starting point. So now the question is, what is the distance that you covered? So the distance that you covered, so BF, is the addition of all the length that you see. It is BC plus CD plus DE plus EF. So all the distances, the length that you see, so you have to add everything. Plus 25 plus 50 plus 100. Okay, and this will give you the distance in meter. So it is 275 meter that you covered. Now we have not specified the direction because this is a distance, it is only positive we do. Now what if we want to calculate the displacement from the starting point? So okay, now we have to define a positive direction. Let's define the positive direction to be along the east. Okay, this is a positive direction. Okay, and now we know that the displacement is given by a vector BF. Represent it with an arrow. So this is XF minus the XB. Okay, and then so we have all these distances to add. Okay, so we have EF, we have ED, DC, and so on, and this will give you EF plus vector DE plus CD and plus BC. So now the positive direction is here along the east. So normally BC is along the positive direction, so we should give him a positive sign. Okay, whereas CD is to the opposite direction, so it is a negative sign. So DE is positive and this is negative. Now we have to just add everything, so EF is minus 100 plus DE is plus 50 plus CD is minus 25 plus the 80, which is a BC. And if we add everything, you will have positive 5 meter. So BF is positive 5 meter. And this is 5 meter from the starting point. Okay, so the conclusion is that U ends 5 meter to the east of the point B. So the conclusion is that U ends 5 meter east of B. So you see we have a direction which is the east direction, and the magnitude is a 5 meter magnitude.